Hey guys, welcome back to the channel. I have a 2009 Mini Cooper base. This is from Shenoy here in Virginia. She sent this module to test because she has a problem with her car on Misfire on cylinder 3. As far as I understand from our conversation, they have repair coils and injectors and it still is doing the same, so she decided to send the computer for testing. I test the computer and everything is good. So I'm going to, for my records and hers, I'm going to perform the complete test so we can see exactly what we have in the computer. I also would like to stress to her that now this will be now a testing on the car that you need to perform as far as mechanical condition. Do a leak down test. It's very common on these cars to burn exhaust valves, and when it's starting is misfire, it can go away and then come back because it's not sealing properly until the point that it will burn completely the valve, and then it will give a steady misfire. This can be performed in any mechanic shop. The other easy way to do is use a borescope camera, removing the spark plug with the piston on bottom dead center, and then you can see the valves, with a borescope that you can like turn. There's multiple borescope that you can do that, and then you can see the valve completely burn or not. But that's only when they're completely burned. If they're starting to leak, then you need to perform a leak down test in cylinder. All right, going back to the computer. This is again a 2009. This is the B number for her vehicle, TW76884. So I'm going to get out of here completely, and then we can reconnect to the car like that, where and she can see that this is a complete connection. So the computer is powered up. I'm going to do an auto scan. For this, I have to provide my own terminator resistor because otherwise I will not communicate because it's not completely in the car. But here, not a problem if I do that. All right, that's again a 2009 Mini Cooper, and we can see the VIN number being extracted from the actual computer. I'm going to then go over to fault codes because that's all I really need, the scanner. Computer is communicating good. I have no issues, and she does not have any issues communicating. I can even inject the camshaft position sensor signal, which I did just to make sure that indeed the computer's logic is good. And the next test that I want to do will be the curve tracer. For this, I have done extensive homework. This is again my own information. You will not find this anywhere online, so don't even look for that. This is me doing. I have marked the coil, the CKP, which is crankshaft position sensor, coil 3, all the injectors on the upper layer of the computer with the pinouts from BMW Mini Cooper website. So this is original information. I did then add my own symbols so I know which one is which. The red arrow will be for injector number 3, and this goes to this IC. This is a IC that is in control of all the injectors. So if one is the only one that is giving problem, that means power and grounds for this IC are good. The only thing that will be affected will be that specific output, because this is a multi-driver IC. This is a smart IC that has diagnostics and everything, and it's in control of like the fuel pump and other things. But for what we're doing, this is going to be my test. All right, so we are now in the menu of selection. I'm going to do a manual selection again because we don't have the entire vehicle. This is an R56 N12 engine. We're going to drive engine ECM or DME, right? Digital Motor Electronics. That's what it stands for. Okay, this is again the last 7 digits of the B number. This is the way Mini Cooper and BMW always ID the cars. We're going to go here. We're going to read the full codes. I want you to see what is in history and what is current. So in history, we do have combustion misfires on cylinder 3. They're not present in here. Again, yes, because It's not happening in here. Current, master flow sensor, throttle battery, and other Valtronic motor activation, and some other faults that she didn't have before. Why? Because um, I'm not having those connected. I only have this portion of the computer for the test that I need to perform for her. I do have everything to perform even further testing on this computer. So I have created the rest of the computer and some other like throttle actuator, pedal position sensors, and so on when I need to perform that test. Not the case for her. All right, so we can see that fault code is in history. Again, it's not happening in here. If we go over to data stream, and this is the only thing that I want to share or show, is indeed that our computer has good communication. So I'm going to supply the crankshaft position sensor signal, and we can see that the engine speed is now 686 or 99. I can change that as I please in here because I'm providing the correct signal, and we can see that it's active, the engine is in idle, and the computer is happy with the signal. How I know which signal do I need to inject? I have done very extensive homework for these specific tests. This is the tone ring right at the back of the flywheel, let's say, right? And it's a 58 minus 2, oh, sorry, 60 minus 2. Let's say that will be the correct. Let me actually, because I think I named, no, I haven't even named it, but let me do that 1 second. Okay, now I name it and that is correct. This vehicle, even though it's a 2009, use multi-port injector. So this is not a GDI. So this is not a common vehicle to have problems with these injectors. Even the GDI, let's say, the GDI, they get full of carbon and end up damaging the injectors. You need to clean the intake passages and so on. Not the case on the multiple port for injection because it's behind the intake valves and that keeps them clean. As far as the crankshaft position sensor connections, I have again all the information specifically with the car. VIN number, as you can see right there, that is from Air original Mini Cooper information. Those are the connections from the crankshaft position sensor, and this is how I know which one is the sensor signal, the power for the sensor, and the ground for the sensor. Yeah, all the information is there. I also have the supply for this computer. This is all powers and grounds are in connected X6304, which is this one. Then we have connector X60211, and then the small one is X60212. Uh, these are the connections, powers and grounds, and the communication, the wake up signal, which is very important, and everything is there, obviously, because we can communicate with the computer. What else do I want to share? Oh, okay, I got let me go over to the non-GDI injectors. I actually put that in the notes so I remember because there is a GDI and non-GDI on this same year model. But you will notice that in this case, all, let's say one side, which is the power side, which how I know is power because we have terminal 87. Terminal 87 is an ignition through a relay that powers something. So that is the power, and then all the control wires are coming from the DME. This is also coming from the DME, but realistically, this is just a jumper from a relay, and then all it does is goes in and out to the injector. Same thing for the coils. But when it's GDI, power and ground will go to a specific pin, like in this case, the control will go 45, 47, 48, and pin 7. If this will be a GDI injector, then the other side of the injector will go to, like, let's say 17, 18, 19, and something else. I'm just putting those numbers out there. They're not the correct, but what I'm saying, they will come from a specific, not from a chair pin like in this case. Okay, so That is the first clue if you want to know if you have GDI injectors or not. If in the car, you will know because you will see the fuel rail. Uh, I have also the ignition coils diagram, and in this one we can also see this is very common for Mini Coopers and BMWs where they have an extra ground that goes into the back cover. Be careful with this ground; it has to be connected because otherwise it will cook your DME. Not the case with her. This is all working good, but I need to know which one is coil 3, and if we follow coil 3 is connected to pin 17. Let me just make sure. Oh no, sorry. Coil 3 is pin 9 and connector X60212. So this is, I am checking the injector, the coils on this computer to make sure that there is no problems with it. All right, so this is as much as I want to share for that information. For any other ones that are looking at the video, let's do the curve tracer test. All right, so let me disconnect this computer from here. I'm going to connect the curve tracer and we're going to do the curve tracer and see the results. All right, the curve tracer, I got it connected to pin 3 or 4 and the X60004. That is the ground. And then the other side of my curve tracer is the one with the lead to do the test. All right, let me open the information, which I have ready to go. Let me just 1 second. Need to open the software. All right, settings that I'm using for this: 5 volts, 100 hertz frequency, and then 1 kilo ohm resistor. This is always has to be very important what you select. Make sure that you keep the same. Let me load the image. This will be the upper section, and I call the upper section as I open the computer the first side of the board that I can see. All right, so let's load the image. Upper section, I have everything ready here. I'm going to make this a little bigger so we can see everything really good. I think that should be good. Now let's load the data. Upper, perfect. And then we're going to select test point 0, and we're going to do auto test. All right, so what this will do is going to add an X on the pins that I need to touch. And the red is the history of a known good computer, and we're going to look for the same results. As I am touching this, if the results are the same, the computer is going to, the software is going to add a green dot onto it. So let me just flip this around because otherwise I'm going to be working backwards. So 1 second. All right, that's much better. Now I am in the same direction as in there, so I don't have to think on which pin I need to touch. Again, red is the history of a known good, and the yellow is the actual. So I'm going to just touch in here, which is that pin, right? And we can see how now the entire square is green. That means it's good. When I release that, that adds, you see that green dot in there? That means it's a pass. All right, we're going to go over to the next one, which is the pin 4 on the next connector. So 1, 2, 3, 4, right here. We got the same green, and when I release, it pass. Okay, we're going now, skip 1, 1, 2, 3, 4, 5, and 6. We got the same result and another dot. So I'm going to now 1, 2, 3, 4, 5, 6, 7. Yeah, it should be this one. And we have a green dot. All right, so all of that passed. Now we're going over to the IC where those signals are coming from. For this, I need to get the microscope. So I'm going to try to do my best to show you to. I'm going to actually touch a ROM pin. So you see the image we have in there and where I'm supposed to touch. It's like the 8th pin, and I can have as as magnification in here, which that's what that in there is. So if I want to see a little more in detail, I can zoom in or I can zoom out. That tells me where I am exactly in there. So if I zoom a little bit in here, that will help me to see the pin better or not, right? So that's what all that is. Okay, so I can see that there is a pin right next to, and hopefully this software picks up in the camera, but I'm going to pick up a run pin because, oh, actually, let me just pick up something that's still, yeah, that's an injector signal or something like that. So let me pick up a run signal. Come on. Ay, ay, ay. Let me, yeah, this one. You see, this is a signal that it does not fulfill the test and it's wrong. So that will put a wrong dot unless I want to proceed with the next test. Let's say, right now we are in like some other thing, but I want you to see that if it doesn't pass, it's going to put a red dot. So I can come back to the test points that I was doing. So let's start to the correct points because I don't want to confuse and say, well, you didn't do the test on the correct pin. So I'm going to come back to that and I am touching it right there. Come on. Yeah, we have a green, sorry, a red, sorry, a green. Well, you can see that the red and the yellow are a match. All right, so I'm going to the next one, and that is moving again to the pins in there. So we're going to make sure that we get the green result. And you can see again the green around. So right now it's all white, and I'm talking about these edges. So I'm going now to the bottom, which I made red. So I'm going to touch in there, and now you see a green around. Let's see that green dot, a red dot should go green, and it went green, perfect. And now I'm going to go to the next one or the last one for the injectors, and that is also green. So that should give me a green result. And I got multiple other areas because I got like 603 test points for this side and so on the other ones, but I don't need to proceed. Her concern as far as injectors is not the injector drivers. Injector drivers for these computers are all good. So the injectors are not a problem for the misfire. So I'm going to move now to the other side of the board and then check the ignition coil drivers. I'll be right back. All right, I flip the board, get the image ready and the correct data. On this side, this is a very simple side of the board. I only have like 26 test points. But let's do the ignition drivers, ignition coil drivers. So we're going to start with test point 1, which I don't see the X for some reason. Let me see, test point 0. Yeah, now it is there. Okay. I was saying that these are the coil drivers, all right? So we're going to do a test, same thing that we're looking in here. The red is the known good waveform, and the yellow is uh, the actual. Uh, when it's like this, flat horizontal, is an open circuit. These are IGBT drivers, so the output of this IGBT has to show open always. If it's short or something else, that means this driver is off or is bad. I will have to skip that because when this software, when it's an open, it thinks that you're not touching the actual pin and it is waiting for a result, which is already the result. But since it's an open, so just so you understand what it will happen or what is going to happen. So let's just start with the first one. I need to get to the microscope. I'm ready, so I will be touching here. This is the first driver, and we got immediately a green dot. All right, so I'm going to the next part, and this is where I am not getting a result, and I'm going to show you that I'm touching there. You see right there, that's the output of that IGBT. It is matching. You see the red and the yellow, so that means I am definitely moving in there, but it's such a small impedance or whatever is on that driver, that this software cannot pick it up. But like, I hope that you can see, I'm going to release it. I hope that you can see on the left side of that image how the yellow is a little higher than the red, but when I'm touching is exactly the same. So all I need to do is then now come here manually and then go over to the next test. So the next test point, which is the next part of that driver. So I touch in here. And when it's a short, that is a short to ground because that is the ground connection for that driver to come, for the coil, right? It is good. So I'm going over to the next driver, and that is a pass. So we have a green. Again, that is being tested. Is the back, all those back needs to be like that. And you will say, well, Mike, well, you just don't check for an open, because it's not a perfect open. It is, as I show there, a little bit of a signal down on the yellow that has to match with the red. And I need to see that. So, all right, so I'm going to go over to the next test point, and we got the green dot on the image. We can see how that is getting green. That is going to be the next driver back part, which is the one I need to skip, but I can see that the image is actually the same. All right, so I'm going over to the third driver ground side, and it's good. That image is good. I'm just going a little fast so we can see the results, because the video is getting a little long. I need to be a little slow talking for her, so the captions on the video will be good. And then the last part on the last driver, just to see that we got all the green dots. So we got all green, 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 green results. All those four drivers, four injectors, sorry, I keep saying injector, for the coils are good. So I'm going to close this in this last image, because I want to show you also the next image that, again, this is my information, lower board with markings, where I have mark which is the driver for each coil. So we can see now, before I didn't explain this because I want you to see that all the results are the same. We have no difference. So the second driver from the top down is for coil 3. Coil 3 driver is as good as coil 1, 2, and 4. So there is no problems with this computer on the coil drivers, and there is no problem with this computer on the injector drivers. The computer is communicating good. So my test results on this computer is working 100%. There is nothing wrong with this. So I'm gonna have to just put it together and give it back to the customer so they can keep going with testing on the vehicle. As my recommendation for experience, I'm also a full mechanic, and I've been doing this for over 35 years. I'm a master technician, and I work for a shop for BMW, Mini Coopers, and Rolls-Royce. So yes, my advice will be to remove all the spark plugs and do a leak down test, and or you can do, I said we'll probably end a borescope test with a camera so you can actually see, take photos, ask your mechanic or whoever is going to do the test to take some photos and give you the results. I like to see things. I am a data analysis person, so when I can taste or touch or see the data, then I can take my own conclusions. All right, thank you guys so much for visiting the channel. Thank you for sending this computer for testing. I hope that you can fix your vehicle and everything goes well. Talk to you later. Bye bye.